In this video, we'll be talking about the graph of y equal cosecant x. Cosecant x is the reciprocal of sine x, so we will consider the graph of sine x and construct our cosecant x curve from that. Now, some things to remember. The cosecant graph has asymptotes where the sine graph crosses the axis. So the sine graph crosses at 0, so we need to draw an asymptote here at 0 for our cosecant graph. Sine also crosses at pi, 2 pi, 3 pi, 4 pi. So all of the integer multiples of pi is where we want to draw our asymptotes. Another thing to remember is that the reciprocal of 1 is 1. And the reciprocal of -1 is -1. So my sine curve hits a +1 at pi over 2. My cosecant curve will also hit a +1 at pi over 2. My sine curve hits a -1 at 3 pi over 2. So my cosecant curve will also hit -1 at 3 pi over 2. So some attributes then of our cosecant curve. Our asymptotes occur at 0, 1 pi, 2 pi, 3 pi, 4 pi. So we would state then that our domain is the set of all x's such that x is not equal to n pi, where n is an integer. Our range, all of this, if we were just to graph the cosecant curve, all of this would be blank in between here, would be just white. So our cosecant curve starts at -infinity and goes up to -1, includes the -1. Then we have quite a bit of blank space, and we hit +1 and go up to +infinity. So the brackets, remember, show that we include that -1 and the +1. The cosecant curve is discontinuous at the asymptotes, so at x equal n pi. We have no x-intercepts. And again, remember, this would be blank. There'd be nothing in here in the space. The period is 2 pi, the same as its reciprocal function sine. There's no amplitude, and it's symmetric with respect to the origin, which means that it's an odd function, and the cosecant of -x is equal to a negative cosecant x.